This is lesson 1-2 of Algebra 1. It's algebraic and verbal models of functions. So hopefully at the end of this lesson, you'll be able to identify independent and dependent variables given a verbal model, and then you can find the input and the output of values of algebraic functions. All right, so vocabulary, again, a lot of the things we're going to look at in this unit are just you getting used to the language of functions. So an independent variable is a variable that represents a quantity that is being manipulated in an experiment. So x is often the variable used to represent the independent variable. So independence variables are like the inputs, all right? So like the input values. And they're often the values you can't control. So you can't control, they're typically the values that you can control. So you can control these. The dependent variable it represents a value a quantity whose value depends on how the independent variable is manipulated. So these are your outputs, and you cannot control in a lot of cases. So these are just rules of thumb, okay, for you can control and you cannot control. That works for most of them, okay? So typically x's then are independence and y's are dependence, okay? Let's look at some examples. I think that'll help you understand these two terms, okay? So you're doing chores to earn your allowance. For each chore you do, you earn $3. Well, this sentence links your chores to the $3. Well, which one can you control? Can you control how many chores you do, or can you control the $3? Well, you're going to choose to control the chores. You can do more and more and more chores, and then what that does is your doing chores impacts how much money you make. So the $3 is the dependent variable. Okay, so money is the dependent variable here. Okay? So you try the next one there. Just think about which one you can control and which one you can't control. So hopefully you chose that you can run as many miles as you want, and then that's going to impact the calories that you burn. Okay, so miles is independent. You can run as far as you want. Okay, and then the more miles you run, the more calories you burn. So the burning of calories depends on how many miles you run. Okay, consider a relationship with the independent variable represents which the independent variable represents the students in the classroom, and the dependent variables represent their ages. So is that a function or not? Well, let's just look at a few examples. Like, let's say that we have a Tim in class, and Tim is 14, and then we have Sarah in class, and she's 15. Okay, and then there's Bob in class, and he's also 14. And then there's Cindy, and she is 14. So you can see what's going on here. So the question about a function or not is, does the x value or the input repeat? So if we have individual people in the room, is it possible that one of the names could be the same? And the answer to that is yes. There could be two different Tims in the room, and they could be two different ages, okay? But I think what we could do is we could be a little more specific with this. We could say Tim R, Sarah M, Bob P, Cindy S, so you've got last names, And that makes the people in the room unique, right? And therefore, the inputs are all different. And it's okay if the outputs match. Remember, for functions, the x can't repeat. You can't have two different ages for each student, for one student in the room. So we could say this is a function as long as we considered their last name, okay, so that they would be unique people. And each person has one age, that's it, right? So that would be a function. Now, if you just considered, first names only, well, then we might have two Tims, and they might have two different ages. So, but I think the spirit of this question is those people are they're individuals, and we can't, just because they have the same first name doesn't make them the same input. Okay, they're two different people. Okay, so that's a good way to think about that. Now, what happens if you reverse that? And so then we kind of just did a little table like this. We'll just go with ages like this and say, you might have Tim and Sarah, and Bob might be 14, and Cindy might be 15. Well, now you can see already there are going to be multiple people who are 13 or 14 or 15 years old. And so clearly, if 13 is the input, the output could be one of more than one name, right? So now we have something that is not a function. Okay? That's abstract. It's hard to think about. We'll do more of those as we go here. So example 5, this is the questions you're going to see. I pulled this right out of IXL. So when you do your homework, these are the types of questions you're going to see. All right, so I want you to be familiar with them. So Destiny is saving money for a vacation to Thailand in the fall. The more money she saves for the trip, the more days she will be able to stay. So it sounds like M, the number is the amount of money Destiny saves, and D is the number of days Destiny will be able to spend in Thailand. Which of them is independent and which one is dependent? So you got to think, which one can she control? Which one impacts the other? Does the money impact the number of days, or does the days impact the money? Which one can she change? Well, she can change the more money she saves. She can change how much she saves. Okay, so that would mean M is the independent, and then D is the dependent. The more money she saves, that impacts how many days she can stay. Okay? You guys try this one. Shut your video off and give it a try and turn it back on. Just pause it and start it again. So in physics class, the students found that it takes a force of F of X newtons to accelerate a wagon that weighs X pounds. Well, what does F of 8 equals 25 tell you? It takes 8 newtons to accelerate a 25-pound wagon, or it takes 25 newtons to accelerate an 8-pound wagon. Well, remember that the X value is the one that is the independent value, and it's going to go in the parentheses here. So it takes 8 newtons of force to have an output of 25 pounds. So this is the input, this is the output, this is the independent, and this is the dependent. Okay? You guys give this one a try. All right, in the spring, Jayla plants sunflowers in her backyard and keeps track of how tall they are. The function f of x gives their height in inches, x days after they are planted. So here, x represents days that are planted. So it says, what does f of 90 is greater than 55 tell you? Well, the sunflowers are over 55 inches tall 90 days after planting, or it takes more than 55 days for it to reach a height of 90 inches. Well, 90 in the problem represents x days. 90 is the x value. So that tells me that the sunflower is over 55 inches tall. This is the height here. And this is days here. So it takes 90 days to reach over. The greater than means more than 55 inches tall. So that's our correct answer there. So function notation, we talked about this in lesson 1, but we're going to hit it again a little bit here. Here's an equation, y equals 9 minus 4x. That represents a function. If you were to graph that, it'd be kind of a diagonal line. It would slope down, like, I don't know if you remember how to graph lines like this, but you would start at 9 and it would go down 4 units and then over 1. So it'd be something like this. Okay? And so clearly that's a function. It's going to pass the vertical line test. But what if I wanted to talk about more than one line? And I didn't want to call them all y. Well, I'm going to give them a name. And like we could say y is going to be replaced with f of x. And now this function is called f. And we can input values x and we can get outputs. So it's read f of x, like we talked about before. And that means the output value represents f. And it corresponds to the input value of x. So the function has an output value when I put an x value in. Okay, so let's look at how that works. So if I say find f of 2, that means what output do you get if we input a 2? So there's our function, and then notice they replace the x with a 2 on the left, and that's just symbolism. All the work takes place on the right side, okay? So I'm going to replace x with 2 on the right, and then I'm going to do the math on the right. 4 times 2 is 8. I've got 9 minus 8. 9 minus 8 is 1. Notice nothing changed on the left side, okay? It simply means you inputted a 2, and the math on the right side came out to be a 1, and I can write those as an ordered pair, okay? So students always get confused about, they think they're going to multiply f times 2. That's not what that means. F of 2 does not mean f times 2. Okay, it means what do you get when you plug 2 in? Okay? All right, let's see if you can give one try here. So we're given f of x and they want us to find f of negative 2. So stop the video, try it, and then check back. So f of negative 2 would be 7 times negative 2 minus 1. So if I put a negative 2 in here, I'm going to put a negative 2 in here. And then I'm going to do the math on the right side. 7 times negative 2 is negative 14. And negative 14 minus 1 is negative 15. So we would say negative 2 and negative 15, they are input-output pairs. Okay? Now look at this one over here, g of x. Give it a try. See how you do. So they're asking us to find g of negative 5. So I'm going to put negative 5 in place of x. And notice I put the negative 5 in parentheses. So if you're going to type that into a calculator, please use the parentheses. Otherwise, it will not give you the correct answer. So negative 5 squared means negative 5 times negative 5, which is a positive 25. Minus 4 is 21. And so we know that g of negative 5 equals 21. So when I input a negative 5, I get an output of 21. Try these two. All right. H of x has to equal 9. Well, this one's a little different, isn't it? Now, instead of me giving you an x value, I'm finding the x, and I know h of x is 9. So I know the output. I'm going to replace h of x with 9. And I don't know what x is, so I'm just going to leave it in place, and I'm going to solve that for x. So I'm going to add 1 to each side. I'm going to divide by 5. And I'm going to get 2. So that means that when I input a 2, I get an output of 9. You guys try the next one there. So this time we're replacing f of x with 6. Just like it says right here, f of x is 6, so let's replace f of x with 6. I don't know x, that's what I'm trying to find. So I replace f of x with 6. I'm going to solve this for x. I'm going to subtract 2 to get x by itself. I should have done that over here too. 4 equals negative x. And now to get rid of the negative, I'll just divide by negative 1. Those cancel. And 4 divided by negative 1 is negative 4. So when I input negative 4, I get an output of 6. All right, so you're going to find that in IXL, there are 3 assignments: identifying independent and dependent variables, interpreting functions using everyday language, and then evaluating. So they should follow examples very, very closely that we did together now. And it looks like you need a SMART score of 70 on those.